doing a video. And I've started streaming them just because that way I don't have to upload them. It's already there and it just makes it easier. Okay, so we are live. Yeah, what is your deal with the Zoom call, dude? Okay. So here we go. So quick reminder while we're talking about it. On your homepage, you should see our agenda, and I keep adding to it every week. And I feel like this is this week's. I feel like I should get like some sort of round of applause for keeping up with it for a whole week.
Cross country, Monday's run will be on Tuesday.
You hanging your hair? What'd they say about cross country? Move to Tuesday? Okay. Okay. So today we're working on lesson 20, letter coefficients, okay? Now, I want to tell you, Taylor, you've paying me attention, you're playing. Thank you, sir. Okay, so I want to tell you, the lesson that we're going to do today looks really difficult when you first look at it, but it's real simple, okay? So don't let it freak you out and just let me teach it, all right? Just stay calm and let me teach. Okay, so we're looking at lesson 20. Lesson 20. So let's close up lesson 19 and open up lesson 20. And we're going, the read it's available for you if you want to try to read it, if you need extra help. But we're going to look at the practice it together. And then I've got to get my split screens going. Okay, and make sure I'm recording the right thing, and I am. All right, so we're going to try to solve this for x. Okay, what do you notice? There's an a and an x together, right? But our goal is to get x by itself. And we're going to use all the same process that we always use. We're just not going to have a number answer. We're going to have an expression answer. So we're going to do the exact same stuff we always do. So we're going to start with, let's draw our middle line, right? Now, what's over here with x we want to get rid of? 5 and 8. Which one are we going to get rid of first? 5. What's it doing to the x? Being added. So how do you unadd stuff? You subtract it. So we're going to subtract 5. But if I do it to one side, I got to do it to the other. So that's, what's 5 minus 5? 0. So we say, oh, they cancel. And that leaves us over here with a times x. And over here we have 3. Right? Now, what's our next step? Remember our goal. Our goal is to get x by itself. What's with x I got to get rid of? A. What are they doing together when they're side by side like that? Multiplying. So to unmultiply, I'm going to divide by 8. But if I do it to one side, I got to do it to the other. So what is something divided by itself? It's 1. Even if that thing is an a. So a divided by a still equals 1, right? P divided by P still equals 1. Right? So a divided by a is 1, but 1 times x is just x. So we say, oh, they cancel. And that leaves me with x over there. And then what do I have over here? 3 divided by 8. And this is my answer. So it's not a numerical answer. It's an expression answer. And we use this in algebra a lot. We rearrange formulas and we rearrange equations that don't have a numerical answer. We just rearrange them so we can find something different. Okay? So this actually has a name. Doing this has a name.
It's from interruption. Could you please dismiss all journalism and yearbook members to the baseball field?
It has a name and I just forgot what it was. Is your internet working? Look, bring it to me. Let me see. Time out to fix a tech issue. It shows it's connected. Shows you have good internet. I'm going to close your window. Y'all, if Buzz went down right now, I'm going to be so irritated. Is anybody's working? I don't think yours is working. Go over there and try it out, and let's see if it does anything different. If it doesn't, we'll figure out what's wrong with it in a minute, okay? She did. Hang on just a second. Let me get them, okay? I was going to bring them down here at once. I didn't have time to in my comfort. You're welcome. They make them. Yeah, but they're acrylic, so they're not great. They're not great. They break real easy, and they don't keep things as hot or as cold as stainless steel does. Okay, so let's look at this one right here. Nope, that's not it. My bad. Let's keep scrolling. So let's look at this one, okay? So we've got 7. We've got 7 minus x over b is greater than 12, right? So we're going to use all the same processes as we normally use. The only difference is when we get to the end, it's not going to be a numerical answer. It's going to be an expression answer, okay? So we're going to draw our line, and we're solving for x, right? So what's over here that we got to get rid of? The 7 and the b. Which one are we going to get rid of first? 7. How do we get rid of that 7 first? How do we get rid of it? So, and I know often we want to say add because it has a minus sign after it. But if we add 7 to 7, does that get rid of it? It just makes 14. So we have to subtract 7. But if I do it to one side, got to do it to the other. So there goes my 7s. This still gives me negative x over b. We still have our same sign because we didn't multiply or divide by a negative. What's 12 minus 7? 5. Okay, now how are we going to get rid of that b? It's okay. Go look on my desk. I didn't see any spare Post-it notes, but you can look and see if there's something laying there. I don't think she did. I think she's crazy. Tell her that I have not seen any Post-it notes in here. I don't know. Okay, so y'all, if Miss Russell ever watches this Algebra 1 video, she's going to know I said she's crazy. I say it to her all the time anyway. Okay, so how do we get rid of that b? What are we going to do? We're going to multiply. We're going to multiply by b, right? But we want to get rid of that negative. So how can we get rid of that negative? What's a good strategy for getting rid of it and not doing extra steps? Multiply by negative 1. Can we just do multiply by negative b? Will that work? Totally works, right? Because what's a negative times a negative? Positive. But if I do it to one side, I got to do it to the other, right? So my b's are going to cancel. And then a negative times a negative makes that a positive. So we've got x right here. Sign switches. Why is the sign switch? Because we multiplied by a negative. And then over here, how do we write this 5 times negative b business? How do you write 5 times negative b? 5b, but what about that negative? Negative 5b, just like that. And that's our answer. That's it. You look slightly perplexed. What's up? Okay, so this is like, and I knew that was going to be the question, so let's talk about it. I'm going to bring this down here so we can talk about it. We've got 5 times negative b, but that's like negative 1b, right? So when you multiply 5 times negative 1, you get negative 5. And then, of course, we're multiplying b, so it's negative 5b. Does that make sense? Okay. Okay. Y'all picking this up fast. That's a different one, isn't it? So we've got x divided by c minus 7 equals negative 5. Okay? So here's our equal sign. Notice it's an equal sign, so we don't have to worry about flipping signs, right? Because if you flip an equal sign over, it looks the same way. Nothing changes. Okay? What are we going to get rid of first here? The 7. Right? I didn't even ask y'all how to do it. I just did it. My bad. I'm sorry. So what happens to my 7s? They cancel out, and I have x over c left. And over here, what do I have? 2. What am I going to do to get rid of that c? Multiply by c. And that gives me 2c, just like this, because 2 times c is the same thing as 2c. When you have a variable and a number beside each other, that's the same thing. Now, I want to do a thing with y'all. I want to take that exact, no, I'm not going to use that problem, never mind. We'll do it on a different one. That's not a good one to do it with. We'll do it with this one. So we've got, I perhaps might want to get a clean sheet of paper. Let's just turn this one over. So we've got 18 minus dx is less than or equal to negative 3. Okay? Let's solve for x, right? So we're going to get x by itself. What do we want to get rid of first? So how are we going to get rid of it? Subtract 18, because it's a positive, so we're going to subtract, right? Okay, so that's going to give us negative dx is less than or equal to negative 21. Now, how are we going to get rid of that d? Divide by negative d. Good point on the negative, Fernando. We want to get rid of that negative sign, and we don't want to do extra steps, right? So while we're dividing, we can just divide by the negative. What's a negative divided by a negative? Positive. And the d's cancel, because d divided by d is just 1. And 1 times x is just x. Now, signs switch. Why do the signs switch? We divided by that negative. Now, what's this? It's going to be a positive. Notice we've got a negative divided by a negative, so that makes it positive, right? So it's going to be positive, and we're just going to write it as 21 divided by d, just like that. Does that make sense? Now, what if I took that exact same problem, and I have 18 minus dx is less than or equal to negative 3, but I tell you to solve for d instead of x. You're going to do the same process, right? You're going to use the same process. You're just solving for a different variable. It's going to have a slightly different looking answer. So what would we get rid of first? So we're going to subtract that 18, right? And that's going to give us negative dx is less than or equal to negative 21, just like we had a while ago. And then what? And then we're going to divide by negative x. Now, that negative is not directly in front of that x, but it still applies to it, right? So we can get rid of that negative while we're dividing by x. So negative divided by a negative is a positive. X's are going to cancel. That's going to give me d. Now what? So positive 21 over x. What about my sign? We got to switch it because what? Divided by a negative, right? So see how we solved for a different variable, but it was a very similar process to solving for a different variable. I think you guys got this. You think you got it? I think you can do this. See how it looked really crazy, but it really wasn't when you started doing it. It's really simple. You're doing the exact same thing you always do.
Correction. Students, if you are in Miss Bullock, Miss Tollett, Miss Bell, Miss Braden, Miss Simmons, Miss Mark, Mr. Waldauer, Mr. Lester, and you dressed up for Color Wars, please go to the baseball field.
Are any of y'all dressed up for Color Wars? You think it's just high school? Well, right, but they called my name. They know what class I have. Well, let me end this video and then we'll find out, okay? This one's crazy.